morning, everyone, and welcome to today's webinar on behalf of the Australian and Aotearoa New Zealand AI for LAM chapter. I'm Basil Dewhurst from the National Film and Sound Archive of Australia, and I'll be hosting today's event with my colleague, Rowan Payne from the National Library of New Zealand. We're so glad you could join us for today's webinar about AI at the National Library of New Zealand. And we have got a rather large attendance today, which is really fantastic. It's so good to see the interest in this group and what we do. So before I introduce our speakers and we crack on with the talks, I'd like to hand to Rowan to introduce himself and to do a welcome from Aotearoa, New Zealand.
Thanks, Basil. Yes, Rowan Payne. I'm DigitalNZ Services Manager at the National Library of New Zealand, Te Puna Mātauranga o Aotearoa. Kia koutou ngā munga, ngā awa, ngā waka, ngā tupuna o Aotearoa me te whenua moemoe a e hui hui mai nei, tēnā koutou katoa. That means to you the mountains, rivers, waka, ancestors of Aotearoa and the land of the dreaming, Australia, that are gathered to here today, and those further afield, greetings to you all.
Thanks, Rowan. I do love that welcome. For my part, I'd like to acknowledge the traditional owners of the lands we joined from today. They were the first storytellers, the first creators of community and culture here, and I acknowledge their elders past, present, and emerging. I also extend my respect to all First Nations people present. I myself am on Ngunnawal Ngambri country, which is where Canberra is located, and invite you to paste into the chat the name of the country you're joining from. Now, today we've got two presentations, and these were initially—
Sorry, three presentations, Basil.
Pardon me, three. I've grouped them as two.
It's three for two.
Yes, all right. So we've got three. These were initially presented at a workshop in New Zealand a few months ago, organised by the Business Innovation Group across National Library, Archives NZ, and Taonga. Apologies for the pronunciation, Sound and Vision. We've recorded the session. We're recording the session today for archival purposes, and I invite you to add any questions you have to the chat, and we'll get to as many as we can at the end of the session. First up, we have Emerson Vandy and Yizhe Zhan from the National Library of New Zealand, who will be talking about using Retrieval Augmented Generation LLMs with papers passed and the New Zealand whole of domain harvest. Emerson is DigitalNZ Systems Manager at the National Library of New Zealand. He has a background in IT systems design and is experienced in many areas of library technology. He's had various roles at the National Library, including Service Manager for Papers Passed. Yizhe is a data specialist in the Digital Preservation and Data Capability Group. He's a PhD in atmospheric physics and has leveraged this expertise in satellite remote sensing, awesome, to aggregate and analyze digital collections. Yizhe's work demonstrates the power of large-scale data analytics, uncovering many new insights and enhancing the way New Zealanders can search and access the library's collections. And next up, we'll have Svetlana Koroteeva and Rich Robertson, who'll talk about auto classification on a recorded music dataset, also at the National Library of New Zealand. Svetlana is a digital collecting specialist with an interest in new technologies, particularly AI. She's currently working on automated workflows using programming languages, and during her master's, she conducted research in building models for the automated classification of library collections using machine learning technologies. Rich is the Metadata Workflow Specialist in the collection description team, and his role includes cataloging the published collections, improving metadata processes and quality, and configuring the published collections catalog. So I can't wait. And without further ado, over to you, Emerson.
There's the mute button. Can you all hear me?
We can.
Fabulous. And can you see a pregnant with anticipation black screen?
Certainly can.
Magic. It's all going perfectly according to plan. All right. Kia ora koutou. I'm Emerson. Kei te kaiwhakahaere ngā pūnaha I roto e te pūnamatanga o Aotearoa. That is, I'm Emerson. I'm the service manager here in the digital experience team at the National Library of New Zealand. I have been working with my colleagues around versions of these talks for a few months. We did this back in March. It went well. We're back again. I've been in the library maybe a little bit too long, and this presentation comes to you from the bowels of the very early hours of this morning. I have 2 small children. I'm a bit sleep deprived. There's not a lot of color. This could go better. We'll see. All right. So firstly, because I'm presenting with Yizhe, who I'm going to paraphrase, is basically a rocket scientist, I'm not doing the deep dive. That's for Yizhe. All right. This is a skim, shallow and fast in the search and web access space. All I can present to you is just, I guess, some of the thinking and high-level view of some of the experiments we've done, and some of the comparisons we've done, some of the thinking that's come out of that. So quick and fast and light, and I hope you're all up for that. And also, yeah, because I did this late at night, I didn't really put any pictures in it, so it's black and white. You could blame the sleep deprivation, or you could blame my papers past background. Anyway, first, starting point. Our starting point was actually to decide what not to do around AI. And this was a really useful approach for us for establishing safety in what was maybe 18 months ago, more of an uncertain space, and this helped us move forward. Back around about that time, you'll recall that there were a lot of conversations around Gen AI that were being shared quite breathlessly and feverishly, and commentary from lots of geeks who were throwing new acronyms around that we hadn't heard of before. And the world's stock exchanges were dominated by hypercapitalism, opening its investment wallet and lubricating everything AI related with money. So that was the backdrop for us. And we didn't really have a lot of money, so we had to take a slightly different approach. We decided to start by using a retrieval augmented generative LLM approach with papers past data. There were a few reasons behind this. We had a workflow improvement for researchers in mind, where text of a set of results could be used to create larger text response to a prompt. The responses generated by this approach seemed a bit more easily grounded in the material that referenced, so that was a nice small plus. RAGs can run locally to the collection that they draw from, and for us this is a huge plus, and it allows us to pay respect to the collections that we serve, which contain significant amounts of information about Māori people, Māori places, and Māori subjects, and it's just not appropriate for us to invite the likes of Amazon and Apple and Google and OpenAI and Anthropic, etc., to just come in and hoover it up so that they can build their own commercially valuable domain understanding for the sake of giving us back an out-of-the-box experience with their branding on it. So having decided that RAG was pretty cool, quickly now go into the experiments we did. There were 2. So firstly, there was one by a clever man called Gustavo Motozuki at Boost, and he demoed a RAG that was built on papers past data and harvested using the Supplejack open source tool. And I guess this is where my talk gets a bit non-linear. And this actually came about by a bit happenstance. We didn't decide to do some AI stuff and then Gus went off and did some work. It actually came around the other way around. We'd been doing some work on an open source tool we developed called Supplejack, which is used for harvesting and normalizing metadata for cultural and heritage objects so that we can serve them to a schema. We'd redeveloped the source code specifically so that we could harvest much larger chunks of data. And we thought, what's a good way to test this? Let's harvest a big bunch of papers past data. So we did that, and it worked, and it was good. And then we thought, okay, so what can we do with this big chunk of data we got? And Gus said, let's do something AI. And we thought that also was good. So Gus got busy. That's just a quick little view, lifting the curtains behind the backstage view. So this all actually came about because we're trying to figure out how to alleviate this bottleneck in Supplejack. And that was quickly done. We ended up with a big chunk of data in an application that Gus built, which was just a simple bespoke little web app with a search box, a prompt response panel, and a search results panel below those. Yeah, it would contain roughly 6,000 pages of papers past content, so 0.0075% of the papers past corpus. It had a 1500 dimension vector model, which is chunky-ish, but that was the default for the components that Gus chose to use, and it had a pretty generous input token allowance, so you could give it some pretty long prompts. Gus spent a fair bit of time tuning it, and in this prototype, that became the focus of what we learned out of this. It became about trying to understand whether we could achieve a useful user experience that was meaningful to researchers, that wasn't just like AI as a, wow, this is a cool toy. We wanted to make it like a proper, meaningful offering to a researcher. What's going to augment what they want to do? What's going to give them something useful? Gus's experiment really focused on that. It was a very basic interface. This is pretty much it. This comes from Gus's demo at NDF last year, November. You could throw it a quick prompt, which you can see at the top, summarize Charles Gordon's cricket career, list some of his highlights. The RAG comes back with this information here, a nice little summary, including his high score of 21 runs in an innings against Oxford. And below that is a list of the articles that this information is drawn from, so you can see where these references come from. That gives us kind of a nice degree of transparency about the material that the RAG is using to generate the information from. You can corroborate it, and it's also useful. A researcher could essentially take this piece of text, copy and paste it, and that's their summary done. Wicked. That's a nice speed up of their workflow. So if you think through the generations of papers past, where you had essentially some browsable PDFs, you know, neat, that saved all that time from driving to Wellington and looking at the microfilms. You look at the second generation version of papers past, where you bolted in OCR-derived full text search, so you can go to the specific occurrence of a word within the corpus. Man, that speeded up looking through those PDFs. And now you've got this feature where you can effectively speed up the process the researcher does, where they've pulled together this big list of search results, and they think through them, and they draw some conclusions from them, and they write them down. This tool provides a similar kind of generational speed up to what we've seen across previous generations of papers past. So we thought, okay, there's something pretty valuable here. This is pretty cool. And just a side note, one of the things that we learned with this was that the vector search model effectively provided quite a cool little job of applying subject awareness to the material that it was searching through and how it applied that within its summaries. So it was just a subtle little something we started picking up on. So Gus did a second demo, and it was kind of an in-house one, and we invited the team from DL Consulting to come and see a demo of Gus's prototype. DL Consulting, for those of you that don't know, are the vendor that developed the Viridian software. Viridian is the application used for the papers past application. So thought they might be interested in seeing this. They were. They went away and they created their own prototype, and their prototype used the Viridian application itself. So this was our second very valuable prototype data point, because this essentially gave us something that was comparable to the current papers past. It put the metrics and the size of the databases and the functions directly into the Viridian application context, so that we could start to connect a few dots. And the initial lessons that we got out of this were around the sort of systems and the scale dimensions, and just given us some enormous value to extrapolate, you know, what would it look like to have an AI RAG instance at the scale of the full papers past collection. You know, we've now got some numbers that we can answer those questions with. And just as a side note, like literally half an hour before coming online to this presentation, I went back to look at the demo, and they've actually done a whole bunch more development, and it's just, they've now added so much more polish. So whereas Gus's prototype was all about the user experience and tiny blob of content and tuning the prompt experience, and DL's was about, you know, checking that the system was viable and deliverable and those kinds of things, they've actually now started exploring a lot of the user experience stuff too. So that's just really cool to see. So very quick pause, that we now have these two complementary data points, and there's all kinds of lessons here for us. This might just be beginner confidence on my part, so take this with a big grain of salt, but we think that there are significant workflow enhancements for researchers. We think these are possible to achieve while also improving traditional search measures like discoverability. We begin to get a sense of the scale and supply chain side required to achieve these benefits. And while we slowly move through understanding what these clever people delivered with the data that we hold, the Gen AI world started becoming less of a charismatic stranger and a bit more of a known quantity. We did some reading, we saw what others have done, and we learned a little bit here and there. And I'm pretty glad that we didn't rush this too much, but now it does feel like it's a good time to work maybe on a business case for doing something cool with proper papers passed and AI. All right, some quick lessons. And I've used the royal we at the start of this one. I'm really sorry, this isn't we, this is me. I might not have been very lateral in my thinking around identifying the things that AI affordances can bring to researchers working with heritage collections. It's really easy for me to come back to some dimension of search when I'm considering big collections, and part of that's just because I worked on papers fast for years. You know, you think of something huge, what's something valuable, how can you do something valuable with it? You find things within it. So put my hands up and say, well, my bias was thinking of applying AI directly to answering search problems. And I'm wondering now whether it's not finding that's hard. You can do a lot of this with traditional search, with Solr, with Elasticsearch, etc. It's actually the doing stuff with what you've found that I think is much more valuable with what we can do with AI. I think that's where the promise is. So just for example, while AI might deliver an OCR breakthrough, vector search can already discover new things that traditional search won't find, despite the presence of OCR errors being present. So that might deprioritize us looking at an AI OCR solution to some extent. Or vector search can also already implicitly reflect subject relationships in text. So that's another search enhancement that's kind of out of the box as well. So going outside the search space and into the task space, where I think there's maybe a bit more value, England. I think researchers would probably find useful something like an inbuilt cross-referencing tool that might compare the events described in a given historic text with authoritative third-party historic sources to corroborate and identify or quantify factual anomalies. That feels to me like a more useful example of a direction to take with AI applications. And something that sort of crystallized that thinking for me was a phrase that David Lanke's used in a presentation around librarianship and AI also recently. He noted the acronym IA, meaning intelligence amplification, which seems like a really, really handy, positive use of AI. So I'm stealing that one like a cheeky magpie. Next, what can we begin now that'll be valuable in the future? And I feel like there's a need for something in the establishing standards or practices space for our sector. We reference authors and works to underpin research assertions, and I wonder if in a Gen AI world, we need to take intellectual ontology a little bit further and provide a reference trail from an event all the way through to a research outcome that identifies Gen AI input within any one of the steps. You know, make that observable. You have an event, you might have a picture of it, a photograph. You might have a written record of it. That might be turned into a book. You know, that book gets catalogued. And then there may be like a Gen AI summary of that book and a receptor does something with that. You might want observability across that continuum so that that is transparent. That strikes me as something that could be really valuable in the future to have that. So something like that would create transparency, and it's an aspect of observability, which I think has a lot of relevance to library and research activity. Also, just the other lesson for me, just people needing community, and this comes out of the March workshop that Svetlana and Yizhe and myself were involved in. We ran an AI seminar and a workshop after that for staff here, and it ended up bringing in people from quite a bit beyond our organization. In the workshop, we gave participants a set of basic questions. We got their responses, and after the fact, we kind of grouped them and themed them just to tease some things out. And there were all sorts of aspects to that. One of the things that stood out for me was community and how broadly across the group, the community aspect resonated for them the most. It was just a really strongly felt theme. It painted this picture of people who wanted to be able to explore a new field in a supportive way, connected with each other. And I feel like that's actually like a really good point in time which to look back and tautoko this group, AI for LAM, and the activity that provides a connecting point for people in our space to do just that. I guess my encouragement and what I'm tempted to underline is one of the biggest lessons around AI that we got out of that workshop is just the importance of sharing knowledge with your peers around AI, interrogate the thinking we encounter, and to listen to people and ask them how you can support them. Also, buy them some sick GPUs. And lastly, some links and reference for you if you would like to see any more of this quick skim. Can't promise any great depth, but there are some breadcrumb trails for you to dig into things if you want. This is a YouTube link to Gus's presentation of the first demo. High-level overview for an NDF audience. This is the Supplejack GitHub repo. Does have some docs in it, but the latest docs are in Gitbook, and they're pretty swish. So if you're curious for some documentation around Supplejack and how it works and what it does, go there. Papers Past, just in case you've never heard of Papers Past, it's a cool newspaper search website. And if you want to connect with me and talk through anything or tell me how wrong I am on any of this stuff or whatever, that's my email address. And that's me. Kia ora koutou.
Thanks so much, Emerson. That's fascinating. Don't forget, people, if you've got questions, pop them in the chat, and we'll do questions at the end. Let's hand over to Yizhe now. Thanks, Yizhe.
Yeah. Can you see my screen?
Yes, indeed.
Okay. Yeah. So kia ora koutou. Good morning, good afternoon, everyone. And my name is Yizhe, and I'm a data specialist from the data preservation and the data digital preservation and the data capability team at the National Library. And so following Emerson's talk, leveraging RAG and large language models for exploring papers past data, I am excited to discuss another usage for exploring our web archive data. And to be noted, we are still at the testing phase at the moment. And but as we delve into the vastness of the web archives, the potential to harness this data for future research and public knowledge is, we believe, is very important. Yeah, cool. Yeah, so first, for those who are not so familiar with the web archive, here is the definition from the Wikipedia, and which a web archive is the process of collecting parts of the World Wide Web to ensure the information is digitally preserved in an archive for future studies. And for example, once captured, the snapshot of the National Library website at this particular time will be stored in one or more WARC files. And these WARC files will not only contain all the related content, such as the HTML, the figures, videos, audios, but also the some metadata associated with them. So how much data have we archived so far? And so at the National Library, our web archive effort includes two ways. One is called the whole of domain web harvest. And so in this way we attempted to archive as much material as possible from specific domains, such as all the New Zealand related domains, .co.nz, with minimal human intervention. And in addition to that, another approach is called the selective web harvest. And so in this approach our library staff will select high-value websites for inclusion in our some specific collections. And over the years, as you can see from these two figures, we can see the volume of both approach archived data have grown exponentially, presenting both a resource but also a challenge in terms of accessibility and exploration. So traditionally, there were these two ways to explore and to access this data. And so on the left-hand side is the very traditional way, like the Web Archive Wayback Viewer. And so this viewer is very similar to the Wayback Viewer at the Internet Archive IA website, and which is URL based. Which in that case you need to know the URL in order to access any archive. And another method is the full text search based web archive. Sorry, so this one is typo. So this one is called the NZ Web Archive discovery platform, and this is a full text search based website, and so at here you will need to type a certain keywords in order to get some results. And so enter into the innovative approach of combining the RAG and with the large language models. Is that a third way? And so earlier this year, researchers from the Harvard Library Innovation Lab gave it first a try, and their system basically contains the of a large language model server, either running on locally or using the other OpenAI's API, for example. RAG framework. This could be LangChain plus Chroma or any other RAG framework. And the third part is basically a user interface. And yeah, so here shows a working diagram of a typical RAG plus large language model architecture at the top, and at the bottom is the specific case for the web archive. And in general, it consists two components. The first one is called indexing, and the second part is called the retrieval and the generation. And during the indexing process, the text information, either from all the text information from the WARC files, either they are from the HTMLs or from PDFs or Word or plain text, they were extracted, chunked, and embedded, and finally stored in one or more vector databases. And when the system received a query from the end user sent some question queries to the system, and so the system will embed this query using the same embedding generation model, and then share and search the embedded query in the vector database. And so after the search, the top K chunks that have very similar contexts to the user's query will be retrieved as the results and the prompt to the large language model along with the original user's question. And finally, the large language model would give a response to the user's query by incorporating the information from this web archive database. So here is a example of so basically here is an example, and so on the right hand side is we're leveraging a local running Mistral 7 billion that very small model local running on a Llama server, and so if we are not using the this vector, like this RAG, this vector database we previously built, then the answer is and if we ask the same question, like, can you give me an overview of the temperature over New Zealand in this year, and because this knowledge is outside the knowledge base in the Mistral 7B model, so that it cannot respond it cannot give a accurate answer. And so if another case is, by comparison, if we turn on the RAG, basically if we link the predefined vector database to this large language model, and then we ask the same question, and because the NIVA website has been embedded, has been ingested into the database, so that the model, the RAG, will search for the relevant information and pass this relevant information along with this original query to the large language model, and the large language model can leverage can then making use of this additional information to answer this user's question. So imagine, so this is a way of querying the archive, not just by using some specific keywords, but by asking general questions and or request a summary on broad topics, like in this case. The RAG plus LLM system will retrieve the relevant document and answer these questions in a proper way. So I believe this method would bridge the gap between the vastness of the archive data and the specific information needed by the user. However, we should also admit that this method also suffers from many limitations from our hardwares. And as a result, only a very small subset is currently tested. And all in all, I think the RAG-based large language model application for web archives could open a new avenue for exploration and not only provide more intuitive access to the harvest data, but also enhance the ability to uncover hidden connections and insights within the data. And this approach can significantly benefit researchers and the general public by increasing the data visibility and making the web archive more usable. Yeah, that's it. Thank you.
Thanks, Yizhe. That's fantastic. What an awesome way to access our web archives. I always struggle with remembering the URLs of various things I looked at in 1996. We'll come back with questions for you at the end. Let's continue, and we'll hand to Svetlana and Rich.
Can you see that okay?
Yeah, looks good.
Awesome. Hi everyone, I'm Rich, and today I'm going to give a bit of a background to music classification at the library and the initial idea behind this work, and then Svetlana will talk more about her work exploring machine learning to classify music. So yeah. Start off with a point that I think that classification of recorded music is always a bit flawed. Music is not static. It's artists and composers and musicians always have the ability to create new original music, and the term genre defying gets used occasionally when describing music that kind of goes beyond classification. There's also the kind of fact that genres change over time, the attributes that make up a genre change, and that can be a challenge for classifying music. And there's a huge growth in subgenre as well over probably the last 40 years. And there's also reuse of terminology in new contexts in music. So I've got an example there of lo-fi music. If you know lo-fi 90s music compared to lo-fi 2020s music, it's quite different. And the classification approach that we use always has limitations as well. We're limited by what we know and how we interpret what we hear, our bias in the process, and that's the same applies potentially for machine learning as well. And the controlled vocabularies that we can use to classify music are naturally reactive in development, and they can be quite slow to update over to cater for new genre and changes in genre. But I still think it's very useful, and I just included some examples of different genre classification and use. Yeah. So the National Library, obviously, we collect the documentary heritage of New Zealand, and we've over time developed a huge collection of New Zealand music, approximately 46,000 releases across all formats. And in cataloguing, we use the following approaches to describe and classify music. A form of composition code in a Mark 21 vocabulary, free text description done by a cataloger, selection of Library of Congress headings, and where relevant, selection of appropriate ngā upuku tuku terms. I'm just going to go into a little bit more detail, so bear with me for the cataloguing speak before I hand over to Svetlana a bit. So the mark-based vocabulary that I mentioned is form of musical composition, and this is a 2-character code that we record, and it corresponds to a term in a vocabulary. So you can see there's RC in this example here, and that corresponds to rock music over here. And so you can also see it's quite a limited vocabulary, especially for popular music, and a large, nearly 50% of the collection sort of comes under popular and rock music. So it's quite limited depth though. And also there's a code ZZ, which means other, and a lot of music that doesn't fit that vocabulary gets categorized there, which is a bit problematic as well. We do free text description, which is kind of a fun part as well, where we listen and use appropriate sources to describe the music. And here's just a few examples here. And we also apply Library of Congress subject headings. And so this is a much more in-depth vocabulary, and it's been developed over time. And you can see with the example I've given here of hardcore music, on the right, you can see that it's a narrower term of punk rock, and it's got narrower terms itself. So there's a lot more hierarchy to it and a lot more specificity. And there's potential to map it to other vocabularies as well. In 2019, we actually stopped adding these subject headings to music records, as it was no longer sustainable to spend the time selecting and assigning these. So, and at the time we faced some large collecting projects and just a general increase in digital collecting. And so since that time, we've actually collected and catalogued nearly 10,000 music recordings. That kind of leads on to the initial idea is, could an AI approach assist with adding subject headings to those 10,000 records that lack them? It seems like a really fun little project where it's not replacing any work that we are currently able to do, and it's we sort of accept that classification is never going to be perfect. Yeah, so I kind of thought that those 3 types of description could help train a model that would, you know, be able to add headings to those records that lack them, and also interested in what other approaches would work. This is where I'll hand over to Svetlana to talk more about the work she's done exploring these ideas and looking at natural language processing and audio classification.
Thank you, Richard. Can you hear me? I'm going to talk about technical part of this project. And for the purpose of this project, we separated some music set. And this music set consists from music file, which are already in our preservation systems and should extract it for this purpose, and also bibliographical records with initial information. There was around 21,000 files, albums altogether, and for training purposes, use around 18,000 of albums, which means more records. So if you look on the right picture, there it's an example of bibliographical record. And in field 008, you can see characters RC, which stands for rock in this case. And it's this point would be main point of classification for this project. In 650 field, you can see also subject headings. And there's some textual fields like 245, for example, contains titles, and 500 fields description and sometimes soundtracks names. It's not much textual information here, but in this project, we would see how it might help for classification. Besides, we have some limitation. First, we would like to see how to build a fully internal model, and also we cannot load our materials to public services as well. And also this set is very unbalanced. As you see on the pictures on the left, there is some of genres which are coded in letters on the left. Has so many examples, like thousands of them, and some others, like for example, valses on requiems have only few of them. That's one of the problems. And then before going to depths of automatic classification, let's remember what machine learning it is. It just basically we can think about it as aggregation of mathematical and statistical algorithm, and core of any math is numbers. So what we need to do first to convert our existing metadata and music to numbers. And let's start with a text. Yeah, it's here. So for those who just stepped into machine learning, just simple example how text could be converted to numbers. This is one famous method which called TF-IDF, like term frequency inverse document frequency. And there's example of sentence. So we're calculating how many times term count in one document and how many documents contain this term, apply special formula and get numbers on the right, which could be then fit into machine learning models. But for this particular project, I used already pre-trained BERT model, which was published by Google in 2018 and improved since then. And it showed very effective results for those materials we have more textual description rather than music collection. And I decided to use it here as well. And then we need to transfer music to numbers. Music could be transferred to numbers very nature because it has frequency, tempo, volume, and pitch, keys, and we can also extract some more technical characteristic like MEL spectrogram and centroid. And for this extraction, I have used Python library Librosa. And it did all work for me. Only I would like to mention that it was very long process. It took for me 2 machines and more than 1 week to extract information from all the files. And then it could be saved into in CSV format, for example, or data frame. And next step just used in machine learning pipeline. So here again, for those who are not very familiar with machine learning, there's examples of, on the left side, you can see examples of machine learning libraries. And we know that machine learning could be supervised, unsupervised. In our case, we are lucky. We can use supervised methods because we have good quality labels, which are a result of our hard work of our cataloging team. And also we are using classification methods, obviously. And this small code on the right, it just basically all standard machine learning. So we are just taking our CSV file and then split by train and test and fit on one of the models. For this process, the best models were XGBoost and Random Forest. They show the best result, but it's not everything as easy, just because, as I mentioned previously, on this graph, you can see that some of the genres have very few examples, and even both XGBoost and Random Forest could handle imbalancing very well, but still they're not working well with those cases, which it's less than 50 examples. It's not much for good classification. And for this purpose, I also used here another method, which meta-learning algorithms, which mammal and reptile, and it required just a little bit of building neural networks. So I splitted test somewhere here, or not test, I mean set data set somewhere on this point, on where is around less than 100 examples, and then call them others, classify with standard method, and then all others also had a separate classification with mammal and reptile algorithm. And as a result, we have CSV file with labels and ready model, but it's just, as I mentioned previously, just intermediate goal, because the main goal for cataloging is just classification first on subject headings, not only the composition code, and we will work on this further. Besides, there's here's the results for classification. I tried both with word embedding and without word embeddings, and the winners were XGBoost model with BERT embeddings, and accuracy was 96%. For reptile, it was 90%. It's quite good percent of accuracy, but it's still, we need to think that the National Library have quite high standard of metadata, and we will see if we can use it in automated workflow or just like inside of a recommender system. Besides, in our set, we have 47 genres, but in Library of Congress, there were 74 altogether, and could be more because they're appearing new one. And how to solve this problem, there is several possible ways. One of them just to bring some music files of different genres outside and train on them, or maybe use some pre-trained model, like for example, the same BERT music, but there is also a problem because this labeling, it's not fit Library of Congress labels, or there are much more interesting solution just to work with other libraries and shared models with them. So this is basically all from me. Thank you.
Thanks so much, Svetlana. That's fascinating work. It really is. I love the fact that you're standing on the shoulders of giants in terms of your catalogers and your cataloging practice in the past, and that's giving you such good results. Rowan, do you want to take us away with our first question?
Yes, thanks, Basil. Yeah, we had a question earlier from Paul. Question for Rich. Was wondering if Apple uses AI in assigning music categories for their iTunes, as the categories are somewhat vague and incorrect at times in this realm. Maybe not an example to follow for categorization.
Yeah, I don't really know about Apple, what they're doing in AI, but I'm sure they're doing something there. Yeah.
Wouldn't be surprised.
Yeah, there must be something going on there.
I had a question for Emerson, actually. I was interested, Emerson, in your discussion about standards and practices, and I was wondering if you could go into a bit more detail about what's actually going on there. What is the current standards work that you're aware of in this space? And where do you see this happening, either in Australia and New Zealand, or how do you see communities like ours dovetailing with that standards work?
That's a question a little bit above my pay grade, I got to be honest. For me, it feels like an imperative. It's a space that I haven't been able to connect with enough. I don't know enough about what's going on, and I mainly see the absence of it in informing the work that we're doing and the planning we're doing, the forward-looking view of what we're doing. When I cast my mind back by analogy to some of the work that took place in libraries around the development of, Dublin core metadata and things like that, that strikes me as a moment in time where we were forward-looking and started thinking about what are the frameworks we need in this web and digital era for describing these digital objects that we're creating through digitization. I've really only raised that because it strikes me that we need to be doing maybe more of that around AI to ensure that we get the kind of transparency outcomes that we want, the observability outcomes we want. Do we want affordances for, the programmatic transmission of those kinds of concepts through the chains of information that get to researchers? So it's aspects like that. I can't give you a better answer than that, I'm afraid.
Yeah, no, thank you. It's interesting you mentioned Dublin Core. I think a lot of that work stood on the shoulders of those working in the MARC and the library space at the time.
Okay. We've got a question from Philip, possibly for Yizhe. I loved hearing about the New Zealand Web Archive. Would there be potential to identify policy documents and make them discoverable?
Yeah, so I think it's technically speaking, is fully feasible, and so all it doesn't matter where the sources are, but is for the policy documents, it's just another source or where the text information come from, and all it's about is to clean up a little bit for the policy documents and run locally to build up a localized vector database, so that make these to basically to digitalize the numericalize these text information into the high dimensional vectors, and then this vector database can link to any of the downstream large language model running locally or from the commercial API. But you need to, one thing to be noted is you need to know know the embedding model, because they need to be consistent with each other. Yeah.
Thanks, Yizhe. Is that what you're interested in, Philip, or is?
Yes, sure. I'm a subject librarian at Te Herenga Waka Victoria University, and we currently subscribe to a database for the access to the policy documents, which is not, it's a commercial company. So if there's potential for a New Zealand-owned government department to harvest and archive and make accessible New Zealand policy documents, that would be brilliant. There's lots of courses taught in the country that need access to them. So that's what I was checking out. Yeah.
Sure. Yeah, I think maybe the accessibility of the web archive is something maybe to be addressed. I'm not really sure what the current status of that is, Yizhe, but is that generally available now? That even the full text search based interface?
Because the size of the whole of domain web archive is huge. It's just like what I just showed, and so we are still before we launch the make the whole of domain web archive accessible. We need to scan. We need to have a full scan of the data to make sure it contains no harmful information. before we release that. But currently we are supporting for some selective web archives, and also for the NZ Web Archive Discovery platform. I will put the link over here. They are currently support the 2 collections. One is the NZ ETC, and another one is the NZ elections. So it has supported the full text search for these particular 2 collections, and I think that we will because the platform is there, and we will put more and more data available into the discovery platform. Yeah. Oh yes. Thanks, Julian.
Great. Thanks,
Yeah,
thanks,
ultimately it
Julian.
could be,
Just put that in there.
sorry, just thinking ahead, maybe if this is possible, then in Digital New Zealand, that could be a document type you can select, policy documents. Yeah, just an idea for the future.
I'll take note of that.
Yeah.
Thank you.
Yeah. I've got the next question, which is for Svetlana. How do you think processing music data without labels would compare as a way to make music collections more accessible? So this is by comparison with supervised machine learning. Oh, you're on mute, I think.
So sorry, just are you asking how accessibility of data could be comparable to?
Yeah, I think it's a question of how if you're using unlabeled data, how would that compare to processing with labeled data?
It's absolutely different workflows, because unsupervised, that's method normally clustering in tree, and it means that it makes more difficult just as, but I think both methods could be combined, but if data is labeled, it's very easy to feed it to existing models. If it's unlabeled, at first need to be, for example, clustered. It's one of the methods, and then just decide, is it clustering good enough, or and then manually label these clusters. It's much more work, and that's why labeling is one of the biggest machine learning problem, which we don't have, because we have already labeled data. We have advantage.
Indeed. Shall we do one more, Rowan? Just noting that we're close to time.
Yeah, we've got one more question, and then we'll wrap up. Sorry, we have gone slightly over, but we'll just if there are any other questions, then fire them through, and we'll keep them for afterwards. But Alan has a question: is anyone working on developing knowledge graph approaches combined with Gen AI to improve results and verifiability, etc.? Not sure who's that is directed at particular, but anyone can answer.
I can answer on behalf of the NFSA. Yes, we are looking at knowledge graphs. So we will be reporting on that at the Fantastic Futures conference that's coming up in October, and that's the work of our digital platforms team. So back to you soon on that front.
Indeed.
Thanks, Ingrid.
All right. Well,
I guess if any of the presenters have any more thoughts on that, we can send something out. Alan, thanks.
Fantastic. Thanks, Rowan. Well, let's wrap. I'm certainly stopping Australians from getting to their lunch, perhaps. Before we finish, I would like to thank the speakers for being so generous with your time and your expertise today. It's so juicing to hear this stuff, especially coming from the NLNZ. What an awesome organisation. I would also like to thank the AI4LAM Australian and New Zealand organising group. Without you, these events wouldn't be possible. And thanks to our chat helpers who've kept the machine running in the background. We really appreciate that. A final note before we encourage you to join the chapter's Slack channel for resources, conversation and connection. Maybe it's that community that Emerson was talking about. You can find that on Google, and we're always interested in suggestions for future events and webinar topics. And lastly, a plug for our the up-and-coming Fantastic Futures conference to be held at the National Film and Sound Archive in Canberra on the 15th to 18th of October in this year. We have pulled together a truly amazing program, and tickets are genuinely selling fast. So if you are interested, you should get in quickly. So on behalf of us all, thank you for attending, and I hope you have an excellent rest of the day.